Google just made their Flash model cheaper and more efficient at the same time. That combination matters more than it sounds. Here's what actually changed, what the numbers mean for your infrastructure bill, and whether you should touch your production config on Monday. On July 21st, 2026, Google pushed two models to general availability, Gemini 3.6 Flash and Gemini 3.5 Flashlight. Both are live now in the Gemini API, AI Studio, and Google's enterprise platforms. Gemini 3.6 Flash is the direct successor to 3.5 Flash. Same tier, meaningfully different internals. Flashlight is a new entry below it, purpose-built for high-throughput, lower complexity work. And 3.6 Flash also landed in GitHub Copilot the same day. Let's talk tokens and pricing, because that's where the real story is. Gemini 3.5 Flash was priced at $150 per million input tokens and $9 per million output. Gemini 3.6 Flash keeps the same input price, $150, but drops output to $750. That's a 17% cut on the price line. Now, layer in the efficiency claim. Google says 3.6 Flash uses 17% fewer output tokens on average compared to 3.5 Flash. On deep SWE benchmarks, long horizon engineering tasks, that reduction goes up to 65%. If both numbers hold in your workload, you're not looking at a 17% savings. You're looking at compounding. Lower token count times, lower price per token. For high-volume agentic pipelines, that math adds up fast. Flashlight sits further down the stack. 30 cents per million input, $250 per million output. That's the tier you route simple subagent calls and document processing through. Google published two benchmark comparisons worth naming. On Deep SWE, 3.6 Flash scores 49% versus 37% for 3.5 Flash. On OS World Verified, a computer use benchmark, it's 83.0 versus 78.4. Both numbers come from Google's own model documentation, so treat them as directional, not gospel. What I'd want to see before fully trusting the Deep SWE number is a third-party replication on a task distribution that matches my actual code base. The efficiency gains on long horizon engineering tasks are the headline, but 65% token reduction on a specific benchmark doesn't automatically translate to 65% on your multi-step agent loop. The sourced competitive shortlist here is thin. The only direct head-to-head in the release documentation is 3.6 Flash versus its predecessor, 3.5 Flash. Google didn't publish third-party comparisons against other vendors' Flash class models in this release, and I'm not going to invent a shortlist. What I can say is that the two-tier structure Google is now shipping, 3.6 Flash for reasoning and coding, Flashlight for throughput, is a deliberate architectural pattern. You're meant to route by task complexity, not just by cost. That's worth noting because it changes how you design your agent orchestration layer. You're not picking one model. You're building a dispatch table. One feature that deserves its own beat. 3.6 Flash ships with built-in computer use capabilities. That means UI interaction, clicking, navigating, reading screens, is a first-class tool in the model, not something you bolt on with a custom browser automation wrapper. If you're building agents that need to interact with web interfaces or desktop applications, this reduces your integration surface area. Fewer moving parts, fewer failure modes at the seam between your agent and the automation layer. The open question is whether Google expands computer use to other models in the family. Right now, it's 3.6 Flash only. Here's how I'd think about this on Monday. If you're running 3.5 Flash in production at meaningful volume, the upgrade path to 3.6 Flash is low risk, and the economics are straightforwardly better. Lower output price, fewer tokens generated. Run a shadow evaluation on your actual task distribution to validate the token reduction claim before you update your cost projections. But there's no architectural reason to wait. If you're building a new agentic system designed for two tiers from the start, put 3.6 Flash on the orchestrator and complex reasoning steps. Route high frequency, lower complexity sub-agent calls to flashlight. The pricing gap between them is significant enough to matter at scale. If you're on GitHub Copilot, 3.6 Flash is already available. No action required. And if you're building agents with UI interaction requirements, evaluate the built-in computer use tool before you invest more in a custom automation layer. The failure mode to watch. Assuming the 65% token reduction on deep SWE benchmarks applies uniformly to your workload. It won't. Measure it. Gemini 3.6 Flash and 3.5 Flashlight are generally available as of July 21st. The efficiency and pricing story is real. The benchmark numbers are Google sourced, and the two-tier architecture pattern is worth building around. Links to the official release post, DeepMind model docs, and the pricing page are in the description. I'm Ada. See you next episode.